Okay. So today we'll look at the 703 kth largest element in stream. This is based on heap data structure, and let me zoom in a bit. Yeah, this is okay. Yeah, I hope you're able to see the question clearly. Go through the question, and this is if you see in neat code, this is the first question in the heap and priority queue. Heap is also called priority queue. And then let's go to the question, and we'll try to implement the heap, because in JavaScript we don't have heap, so we have to implement our own heap in order to solve this question. So the question says, design a class to find the kth largest element in a string. Note that it is the kth largest element in the sorted order. Note that kth largest element in the sorted order, not the kth distinct element. Implement the kth largest class. Kth largest, we have given the kth largest like this. K and the nums will be given. Initialize the object with integer k and stream of integer nums. Int add appends the integer value to the stream and return the element representing the kth largest element in the stream. Okay, so the question is like, if you see here, we have been given the kth largest, so this defines what we are initially given with. So k value is 3, and the nums is this guy. And so what we do is, this is the initial set given to us, and when we add 3, we have to return the third most. This 3 signifies that third most large number we have to send. So if we see like 4582, so what is the third largest element from there? And this would be 854. 4 would be the largest element, but when we add 3, does that change this equation? 854 would still be the. So let's take this guy. Can we just copy paste this here? Or increase its size somehow. Okay, okay, yeah, we can increase its size. Cool. So we are able to do this. I hope this is clear, but if it is not, then I can simply write over it. So give me a second. And so this Miro is taking a bit time. Okay, so what we have is, we k is being given as 3, and then nums is equal to 4 5 8 2, and we are going to add later on. We are going to perform addition of these elements. Let me write it here. 3 5 10 9 4 are going to be added later on, so don't worry about this now. But we have been given this initially. Now that we know what we are given. So yeah, here, to signify a heap will, what do I mean by heap is, we'll create a min heap out of the nums, and it will look like this. So we will have, min heap will always have the smallest number on the topmost element, topmost topmost node. So 2, then it will have 4 5, and then 8. And always remember that the heap always node formation is from left to right, and in array you can signify this as heap stores all the nodes, like all the values in a array like structure. You can simply say 2, 4, 5 and 8, 0, 1, 2, 3, and you can always find the smallest value from the topmost element. So the idea behind using MinHeap is that um, what we can do is we can just, so the size of MinHeap right now is 4. What we can do is we can remove all the small elements until the length of this heap becomes equal to k. Okay, k, which is 3. So what we'll do, we'll get rid of this guy, we'll toss it in a dustbin. Okay, we toss this in dustbin, and then this guy so the MinHeap changes here, so this guy goes away. So what we do is uh, we we put this element, like the last element, which is 8, in the position of 2, so it becomes the topmost element, and we remove this from here. And but this does not satisfy the condition of a heap. So what we need to do is we need to check if any of the child of the current top node is smaller than the parent. So we check with left, it's 4. Okay, so we found it in the first go. So we have 4, and then we swap it with the topmost node. So we swap these two. So this will give us, so this will bring 8 here and 4 here. So which means that this satisfies the MinHeap condition. Now we have 4, 8 and 5, like so. The array will look like this. Array will look like 4, 5, 8. This will be array, and then we can simply return the topmost element if asked for. But this is not the case, so we do this, and what we'll do is then we'll add 3 to this guy. Okay, when 3 will be added, 3 will be pushed onto the array, which means it will be let's add 3 here and 3 here. Okay, so now this does not satisfy the heap condition, as this 3 is smaller than its parent. So what we have to do is bubble up. There are two terminologies, bubble up and bubble down. So let me get rid of this guy. Okay, so this will bubble up. So while bubbling up, what we do is we check our parent, if parent is greater or smaller. If it is greater, then we swap it. So we'll swap this 8 with 3. So that will give us 8 here, 3 here. Now 3 has changed. Now again we'll check if this is the right position for the 3. Then it will be checking it with its parent. So its parent is greater than the 3. So we again swap. So let's get rid of this, and then 4 will be here, 3 will be here, and this will change our array, and the array will look like 3, 4, 5, 8. But wait a minute, so once we do that, we are not satisfying the condition of k. Our array is greater than k. So what we do is we get rid of the element. When we add 3, but but it is not satisfying the kth element, so we get rid of this. Then again 4 is returned, so 4 is returned as output. Let's call this output. And then we have this, then 5 is added, then we add 5. So what? Okay, so on removing 3 we again put 8 on the top. Then 8 is again it bubbles down, meaning it satisfy the MinHeap condition, and the array again becomes like 4 8 5, like this. Then we add 5. Then once we add 5, then again we'll do the bubble up, and once we do the bubble up, we'll get this 4 5 5 and 8. So our array will look like this: 4 5 5 8. But wait a minute, we are crossing the k value, k length, so we need to pop the topmost element, which is the smallest element, to satisfy the condition. So we again pop this and then return 5. So here we'll return 5, and this will change our structure to 5 5 8. Okay, and then we add 10 to this. This will again change the structure 10. So it will be 5 5 8 and 10. Okay, so our array will look like this: 5 5 5 8 10. This again violates the condition of k length. Then we need to get rid of the the topmost node. Then we got the largest third value, so we send 5. So we repeat this process. I hope you get the idea. We repeat this process for the later on values. So let me see. Okay, 5 8 10 were the remaining values, right? 5 8 10 were the remaining values. So we added this much, and then 9 is added. Then we 9 is added. So we have to make sure that it satisfies the MinHeap condition. So 5 8 9 10 would be the MinHeap, and then 5 would be cancelled out because k was 3, and then 8 will be returned. And when 4 is added, so the MinHeap becomes 4 8 9 10. Then 4 is removed, then 8 is returned. So this is 4 5 8 8 would be the answer of the 4 5 5 4 5 5 8 8. That's what we got here, 4 5 5 8 8. So that's how you have to do this. So I hope you got the bubble up and bubble down process. It's a bit like you have to whenever you add a number, you have to check if it would be the smallest element, then you have to bubble it up, and then when you remove an element you have to bubble down. So that's the important thing to know. So I'll make a class MinHeap, MinHeap, and then we have to make a constructor, and as I said, everything would be stored in array like data structure. So we'll create this array. Okay, and then what we have to do is, first of all, we have to insert a value, right? We have to create the heap. So we have to initially send all the num values to the heap. So we have will be insert. So we have to check if this we can do this dot heap dot push. We can push the value and push the value, and if this dot heap dot length is greater than 1, which means we need to start heaping. We need to heapify. Heapify means bubble up or bubble down. So I'll simply write this dot bubble up, because we are pushing at the end of the loop, the array, right? Bubble up, and then pass the length. We always pass the index, and with the help of index we find its parent node, and then we check if parent is smaller or greater, and based on if it is greater, then we swap it in case of minimum heap. So we send the last, so when we push this item, it would be the last node of the array, right? So that's why we send in -1, like length -1, heap length -1. So let's see what bubble up will do. Bubble up will take an index, right? Okay, so if the index is equal to, or if it is less than equal to 0, then we don't want to do anything, right? Because at the 0th position there is nothing more to look above, like there won't be a parent, so we don't have to do anything here. And then what we do here is we check if we find the parent node. First of all, let parent index be, what we do here is math dot floor, so as to not get any integer values. We divide index -1 by 2 in order to get the parent index. So whatever, so 1 2 3, so if we add 3, then in order to find the parent of 3, we have to do index -1. So index is 2 minus 1 is 1, and 1 by 2 is 0.5, so we floor it to 0. So that's how we'll get. So this is 0, this is 1, this is index, right? So we'll get the 2, and then 2 minus 1 is 1, 1 by 2 is 0.5, but we floor it, so we'll get 0. So that is the parent. I hope this is clear explanation. And then what we do is we check if parent index, the value is dot heap of parent index. If it is less than this dot heap of parent of the index that has been given to us, then we don't have to do anything, like, because the parent is smaller than the inserted node, then we don't have to do anything. in case if it is if the current inserted node is smaller, when let's say suppose 3 2 1 3 5 1, okay, so 1, so 1 is inserted, so 1 is definitely greater than its parent, so we need to swap those elements, right? So we'll write a swap, we'll send a parent index and the current index. Oops, sorry, my bad. Okay, so we have to do this, and once we have done that, then we have to again check for the parent index, like if we swap, then we need to check if there are any other nodes above the parent, like if we have a bigger 3 5 7 4 or 9 and we insert 1, so we have to keep on checking the parent of parent, so 1 will be 3 3's childs are 5 and 7, 5's child are 9 and 1, so 1 is inserted, then 1 will check here, then 1 will again be checked with 3 because 3 is child were, okay, so you get the idea, right? We have to bubble up until we reach the last like until we check it with the last element, or until we find a node which is less than the inserted value. Okay, you get the idea. So index, we swap it to the parent index, so we have to send the parent index again. So that's it. So this is the recursive one, recursive approach. So yeah, that's that, and we have to write a swap functionality. So let's call it ing, and let's use a shorthand of JavaScript, I comma this dot heap of j and this dot heap of then reverse the order, j this dot heap of I. So let me go ahead and bring this guy here. Okay, that's better. So once we swap this guy up, then what we need to do is we need to go here. Okay, yeah, we swap this up, we go here, and then okay, when we have to extract, like delete the topmost element, that will take care of it. Extract minimum. So extract minimum will check if this dot heap dot length is equal to 0, then we have nothing to return, right? So we'll return nothing. Else what we'll do is let minimum is equal to heap of 0, this dot heap of 0, right? We'll store the minimum, and then we'll swap this minimum with the last element heap dot pop. So this dot heap of 0 will swap it with the last element, and then we'll check if this was not this heap of dot length. If length is greater than 1, then what we need to do is we need to bubble down now. This dot bubble down 0, because we changed the this value, right? change the topmost value, and to satisfy the heap we need to bubble down, and then I will simply return minimum. I hope I'm doing it right. This is I guess I hope to get this question, but if it comes I need to be ready. But yeah, it's too much for a JavaScript developer to know in a heap and implement. So not to know but to implement. Yeah, and bubble down, in bubble down you again accept the index, and then here are a couple things. So we are going from top to bottom, right? Let's say we added 8, 3, 2. Okay, we are going, so this is 0, 0, 1, and this is 2. So in order to find, so 0, we are going from 0 to bottom, right? This 3, 2 are the children of bubble down, right? So what we have to do is we have to, in order to take the left child and see the left child, we have to do this calculation. 2 into index plus 1 will give us the right left child, and right child will be 2 into index plus 2 gives left child. And what we assume is that parent index is the, or the minimum value index, we consider it to be the index that we have passed, and we check if left child is if left child's length is less than this dot, sorry, let's create another variable, heap length is equal to this dot heap dot length. Yeah, so heap length, left child is less than heap length, and this dot heap of left child, check if left child is smaller than this dot heap of minimum value index, or let's say parent, because there is child parent index, let's call it parent, okay, to avoid confusion. If left child is less than the parent index, then we want to change the parent index to left. Let's bring this this condition is quite long, so left child, and if right child, and also we have to do we have to identify which is the smallest one, so heap length, and this dot heap right child is less than this dot heap of parent index, then we again update index is equal to right child. So finally after this two, we know either the left was greater or right was greater. So yeah, once this happened, we check if the initial index is, so if the initial index was changed, which means if we assigned it to parent index, if the value is changed, then we know we have to swap, because at this this signifies that we have identified a smaller value than the index that was passed to us. Then we simply swap this dot swap index and parent index, and similar to uh, the bubble up, we also pass the bubble down. We have to reach till the end of the uh, heap to bubble down the element if it is not satisfying the heap condition. So in this case, we want to send the parent index, right? So here we swapped parent index with this index, right, value. So now, yeah, so now the parent index will be having a larger value. So we need to send the parent index. I'll highly recommend that you take a bubble take an array and form a bubble graph, like heap tree out of it, and then do such operations, so to wrap your head around it. So yeah, once you do that, then this becomes easier. Okay, we don't have to do anything else after this. And then yeah, this is pretty much it, if I'm not missing anything else. And this would be it. These were the main. Bubble up and bubble down are the main operations that you need to be careful about. And okay, so what we'll do here is nums. So first we have to add nums for the num of this dot nums. What we have to do is add those in first we have to create this dot heap object new min heap. Okay, and then this dot heap object dot insert num. Once we insert the num, then what we have to do is delete the minimum value until the size of the heap is equal to k, right? So what we do is create a function. So we have to create a function like this: get largest dot prototype dot delete until, or let's call it check integrity with k is equal to function. And here we have to first check if this dot heap obj, let's also define a length, size, this dot heap dot length. Okay, return this. Okay, so if we just use size, if size equal to 0, then we cannot delete anything, right? And then while this dot heap obj dot size is greater than k, what we have to do is we have to this dot extract the minimum out of it until it reaches until it gets equal to k. So that's how at every time we add a value, we'll get the k largest element. So yeah, here we have to call this dot check integrity with k function, and then what we have to do here is that here we have to add this dot heap obj dot insert value. Once we insert the value, we have to check this dot check integrity with k, and we need to return the topmost value. So we'll again create a small small function to pick the smallest value. So we'll just write if this dot heap dot size equal to 0, then we simply return, or else we return this dot heap of 0. Okay, sorry, this not okay. So that is what we return, and then return this dot heap. Okay, sorry, return this dot heap obj dot peak. Once we peak, we'll get the eighth largest element. Okay, so this is it. We should be able to get the value. So we'll obviously get some prototype, some errors, silly errors when we are key, this dot key, yeah, this dot key. Okay, this is accepted. Cool. Let's see. Oh, I was able to solve it. Cool. That's a good thing, because I did this on fly. I understood it first. Hopefully this is helpful to someone, because there is the JavaScript doesn't implement heap or priority queue on its own. We have to create our own. So yeah, that's all guys. Thank you so much. Bye bye.